Today, we are going to be taking a look at LangGraph. Now, LangGraph is another library within the LangChain ecosystem, and what it allows us to do is build very highly custom and flexible agents, which I believe that agents are the sort of short-term future of AI. Now, you can build agents with the core LangChain library, and I've spoken about this a lot before. But from experimenting with both LangChain and LangGraph, I'm still forming my opinion, but I think LangGraph is simply a much more powerful solution for building agents. Now, let's take a quick look at the general concept of what LangGraph is. Now, as you may have guessed by the name, LangGraph has a big emphasis on graphs. So whereas LangChain thought of agents as objects that you kind of attach tools to, insert some prompts, so on and so on, LangGraph instead thinks of agents as more of a graph. So you have your initial starting point. That could be anything. Well, it's a function, some sort of runnable function. So that could actually just be an agent. Or it could be a chain, or it could be some other runnable function. Now, from here, rather than just finishing with this agent, we can control what happens next. So down here, we might have something like a search tool, right? So we could do RAG in this way. So we could come down here and we could say, okay, this is our search tool, and this is going to get us information based on what the agent or chain has decided up here to do. Then from there, we could continue. We could finish with another either LLM, more likely than not. So an LLM. And that LLM may have a prompt where it consumes the context that you got from your search tool, your initial query, which would have come up here from your user, consumes both of those, and then it will output an answer, and that answer will go to the end node. Okay, so this is a very simple example. Now, whilst we're looking at this, I just want to point out a few things. So here, this circle is a node. Here, this arrow is an edge. And everything in our graph basically consists of nodes and edges in some combination. Now, this is an incredibly simple agent. Let's have a look at something maybe a little more realistic. I'll keep it simple still, but still a little more realistic. So we could start with an agent up here. And this agent actually has a few tools that it contains, but it will use them via function calling. So it won't actually execute the tool itself. It will just output the input to a tool that we should use. So I'm going to connect to this agent the schemas for a final answer, because I'm going to create a slightly different final answer than usual. I'm going to have a final answer where you get an output from your agent and also a citation. So it's it's like a JSON output in a particular format, and we want to enforce that. And I'm also going to input that search tool from before. Okay. Now, this agent is going to output which one of these tools we should use and the parameters that we should pass to it. Now, because there are two tools here, we have two alternative paths that we could go down. And this is another component of LangGraph graphs, which is called a conditional edge. Now, a conditional edge is what it sounds like. It's an edge or a couple of edges that are conditional on some sort of condition being satisfied. Okay, so the condition being satisfied here will be whether our agent has decided to go with the search or the final answer tool. Now, to implement a conditional edge, we need something called a router. And that router is basically an if-else statement. Then, based on that, we can go, well, one of two ways. We can go to our search node over here. Or we go to our final answer, which is actually going to go to the end node. Now, with the search, we're going to perform a search and return an answer. What will that answer look like? Well, we will be outputting some context. Okay, so the output of this is some text, basically. Let's put context. Now, that isn't an answer by itself. It's just some text that we've pulled from somewhere. It hasn't been formatted into a natural language answer. So we now need to pass this through another LLM, we will say, rather than an agent, because an agent is nice when we have multiple tools. In this case, we just have one tool that we want to use, and that is the final answer tool. And all the final answer tool is doing is creating that format for us. So we're going to say, okay, you need to provide an answer and a citation. And from there, we have our final answer, and that will go to the end node. Now, this, again, is a very simple graph. There's nothing particularly complex about this, but it is just far more flexible and far more easy to work with than at least what I'm used to in LangChain. And I have not been using this for a long time. So I think there's a lot of potential to using LangGraph and just learning it. And I think when it comes to building agents, so far, this is by far my preferred method or preferred library. Now, that is a quick overview. Let's have a look at how we actually implement all of this in code. So we're going to go into this notebook here. There'll be a link in both the description and the comments for you to open this same notebook, and you can follow along. Now, there are a few additional things that we need to do here. And this first thing is to install this library here, this PyGraphViz. PyGraphViz is not needed to use LangGraph. It is needed to visualize graphs that are built in LangGraph. So if you're just developing with this library, you don't need this. But yeah, for this example, taking you through things, it's very nice to be able to visualize what you're building. And we have a few libraries that we need here. It's all the LangChain ones. We are going to use OpenAI here. So yeah, we will initialize that. And we move on to our graph state. Now, there are multiple ways of doing this. You can create your own graph state, which is what we're doing here. Or you can use built-in, I think it's like message state that are built into the library, and you can just use those. It depends on what you're wanting to do. I prefer this method because you can define what is in there, and it's just easier to understand. And this has taken some inspiration from a very good video from Sam Witteveen on the same topic on LangGraph. He did a really good intro, actually. I would recommend that as well. So what we are doing here is we're defining this agent state, and as we go through each node and as we pass through the graph, we have this agent state that goes with us. All right. So as we go through, all of the new information, for example, from our search tool that we retrieve, will be stored in here. And you'll recognize this. So intermediate steps. If you've used LangChain agents before, it's very typical. So intermediate steps are, okay, between the user asking a question or typing some sort of query and the output that you get, there can be many multiple steps, as we have seen in that graph, and we store the information from them in here. And another thing that we have here is this agent out. This is output from an agent. There's nothing fancy there. The other thing is the inputs. So that's the input from the user. And we would also have chat history in here as well. I'm not including it here because I just want to strip things down to like be as simple as possible. But that being said, we're going to build like what I think is a very cool agent using LangGraph pretty soon. I'm working on it. That will be interesting, far more complex, and I think it will show us a bit more of what this library can actually be used for. But this is a good intro. So first thing I want to do within the graph is define those different nodes, okay? So the two tool nodes that I want to create are the search node or search tool and the final answer tool. So here we are, we would usually implement a RAG pipeline here, but I'm just going to emulate that. So I'm going to say, okay, this is the information that we're going to retrieve from our RAG, our emulated RAG pipeline. It's from an archive paper on some embeddings. In there, we have the title of that paper, we have the summary, we have the authors, and the source. So it's going to be up to our LLM, the final answer LLM or the initial agent, to decide how to build the citation when it gets this information. And of course, the answer as well. So yes, that is our information for our emulated search tool. And we are going to define the search tool, which is just here. When we define a tool, we use this tool decorator here. We name the tool. We pass, okay, what needs to go into that tool? So we just have a query here. This is like the schema. And we give a description here. Now this description is, okay, it's for us, but it's also actually for the LLM. Okay, it's for our agent. It will read this and decide which tool to use and also how to use it based on what we put here. Now, in here, you'd put your RAG stuff, but I'm just going to return the sort of emulated content there. Then we also have that final answer tool. Now, the final answer tool, it doesn't do anything, right? It doesn't do anything. Like you can see here, it's just returning empty. The reason it doesn't do anything is because it doesn't need to do anything. All I'm using this for is to tell my LLM or agent to use this structure when it's outputting a final answer. So the LLM or agent is set up to use this as a tool, but when it uses the tool, all it does is generates what should be the input to that tool. It doesn't actually execute it. So, I mean, that's all we need. We just need this format. We give it a little description here explaining what we want in both of those fields, and the LLM will produce that for us. Okay, it just gives us the final answer in that structure that we need. Both of these we're going to be executing via OpenAI tools, which is the latest version of their function calling, and you can kind of see how that works here. So if we see search tool, we pass this information to our LLM. So it's going to see, okay, this is the search tool. To use it, it will need to enter the word search. Then we have this description. So this is the function. This is the inputs to that function. And then it tells us searches for information on topic AI, so on and so on, right? It's just what I wrote up here. Okay, so we have that. Then we're going to come down a little further and we're going to initialize our first agent. Now, that first agent, I'm actually going to be using the core LangChain to just implement a very simple or typical OpenAI tools agent. All it will have is a prompt, which I'm just getting from the LangChain hub. It will have our LLM, which is it's a chat model from OpenAI, GPT 3.5. I'm not actually sure what the default is now. I assume it's still 3.5. Yes, GPT 3.5 Turbo. And we have our tools. Okay, so the final answer tool and the search tool. Now, you'll need to pass in your API key here, and then you can run. Okay, and we can just test that very quickly to confirm that it works. So I'm going to ask it, what are EHI embeddings? Yes, we run that, and okay, you can see it outputs this for us, this tool agent action, and this is what we're going to be using in our router for those conditional edges later. So we're going to be looking at the tool item there, and we're going to then be taking this tool input, taking that as keyword arguments for our function, so query, and in that query we'll be passing EHI embeddings. Now, of course, we're just emulating RAG here, so it's not actually going to do anything other than return that text for us, but that is what we would actually need. So, okay, we'll keep going. Oh yeah, I'm just showing you here what we'd actually be outputting there. So we'd be taking the function, we have our arguments, and we have the name. Okay, cool. Then, okay, what else do we have? We're going to define nodes for our graph. So we defined the tools and the agent, and now we just need to define the functions that are going to run as nodes within our graph. So we have the run query agent. It's going to consume our state, and it is going to run our query agent. So the query agent I defined, where did I, here. Okay, so that's the one that makes decision between final answer and search. Then we're going to execute our search. So it's the function for RAG. Obviously, it's emulated again. We have our router, which is what we use with our conditional edge to decide which direction to go in. And that kind of covers that first component of our graph. So basically all of this. But we also have this component here, so these connections. Okay, so search tool, we have defined this, but we do need to define this final answer LLM. Now, the final answer LLM, something that is quite useful that we can do is we can create our LLM, we bind a tool, so the final answer tool, to our LLM, and then we can say that the LLM must call that tool. So this is just to help us reduce the likelihood of it hallucinating and doing something else other than use the tool, because we want to enforce that it does output that sort of structure that we'd like. So we can do that, and it's pretty cool. I'll show you how. So we are here, we have our LLM. This is the one we defined earlier. It's just our chat LLM, and then we bind tools to it. We just bind one tool. It's the final answer tool. And then we enforce the tool that it has to use. We're going to say you must use the final answer tool. Okay. And yeah, that's the LLM. We do need to define a function to handle that. So we have our RAG final answer. We're taking the user inputs from our state. We're also taking the context from the previous steps, so from the intermediate steps, feeding both of those into a very simple prompt here where we just have the context and the question. We invoke on our prompt. So we run the LLM, and that will output a function call, okay, to our final answer tool. Okay, and then we just return that. Now, the final one that we are also going to add, so I didn't visualize this before, is this handle error. So what we do have with the query agent is that it's not forced to make a function call. So sometimes, basically, when you say something like hi or hello, like a very short message that is very conversational, the agent will want to respond in a without using any tools. And I'm sure you could prompt this to be very rare, but nonetheless, it will still happen sometimes. And to handle that, we can actually create another function. This is going to still use this final answer LLM, and basically what it will do is the router will take a look at our output from our agent. It should see either search or final answer, but if it doesn't see those tools being used, we're going to assume there's an error, and then we're going to enforce the use of that final answer. Okay, just like that. It's pretty straightforward. So we do that. Now we've built all those nodes, we've built all that logic. Now it's time for us to put it all together to construct a graph. So we initialize our graph first. We do that with this state graph object, and we pass in our agent state that we defined earlier. And then what we do is we add some nodes. Okay, our query agent, which is our query agent. We have the search tool, we have this error handling tool, and then we have our RAG final answer formatter. Basically, it takes our original user query, the output from the RAG tool, puts them together and produces a final answer for us. Then we also define where in the graph we begin, which is with our query agent. Okay, so we set the entry point. Okay, we run that. Okay, then what we need to do is define our edges. To define our edges, what we do is we add an edge. I think it's literally add edge, and we just say where we are coming from. So we could be going from the agent here, so this would be our X, and where we are going to. So in this case, it would be our router. And yeah, I mean, that's how we do that. Because we have defined the nodes in our graph using strings, it's just what we do. We will also define most of these as those strings. So the agent, for example, we defined as a query agent. It's a string. So that is exactly what we would put inside X here. The one exception that we always have to this is our end node here. So the end is actually it's a function, or it's an object, and there's no string value linked to that. So we just pass in the actual end method, which we'll see in a moment. So let's do that. You can see some examples of what I was talking about. So we add an edge between our search node and our RAG final answer node, and then we can add another one between our RAG final answer and our end node. Okay, so here I have some repetition actually, so let's remove that. Okay, so we import that end node there. We add our edges, which is what I'm doing here. So these are the single edges, they will be taken. So if you go to the search node, you will next go to the RAG final answer node. If you go to the error node, you will go to the end node. And same here. The one other thing that we have here is this conditional edge, right? So this is what I mentioned before. For a conditional edge, you can go in different directions depending on a particular condition. Now, the starting point for that is the query agent. That will then go to our router, which will decide which direction we go. Okay, so that router is going to output a string, which is going to be either search, error, or final answer. And based on that output, we will either go to the search node, the error node, or we will go to the end node. Okay, it's pretty simple. Once we've done all of that, we can compile our graph. So we run that. And then the thing that we installed earlier that I mentioned is this, so that we can visualize these things. And you can you can see what we've built here. Okay, so we have our starting point or entry point, which is actually just the query agent here. We go to our router that decides where we should go. If there's an error, we go to the error that will format our force that structured output. We can also go to a final answer tool, or we can go to the search tool. If we go to the search tool, we do our emulated RAG in this node. Then we pass the state, which includes both the context and our original query, into this final answer LLM, and then we end. And that's it. It's pretty simple. Now let's see how it runs. Okay, so we can see the path that it's deciding to take here. So we're asking, what is AI? Okay, so our search tool is defined as it should be used when someone is asking about AI. So we have our starting point, which is our query agent, goes through to the router, as it always will. And our router decides that we should use the search tool, right? And it's deciding that based on the output from our query agent. So all it's doing is passing the output from the query agent and then deciding, okay, which direction do we go? We then execute our search, and then we go to our final answer LM, and then we finish. And we can see here, we can see what we get, right? So we have the answer. There's some answer. And then we also have our source. Now the source here that it's using is not actually our EHI embedding source, because it's embeddings in the same way that we use RAG in AI to do RAG to search, but it doesn't describe what AI is, right? So the LLM is actually not using our information, even though we've given it that information, and instead it is using something that is remembered, which is the Wikipedia page on artificial intelligence. And this link should actually work. They usually do. Yeah, so you get this. It always surprises me how much LLMs remember, like just random blog sites or websites. Obviously, this one is a less impressive one, but they come up with some crazy links sometimes. Cool. So we have that. Now let's try something else. I'm going to ask what are EHI embeddings, and we can test the citation ability of our LLM now. Let's see what it gives us. Okay, so it's using that context we provided it. It's this is basically just information from that context, from the emulated RAG pipeline, and then we have the source here, and that source again will work. Okay, you see here, that's the paper. And this is a relatively new paper, and we're using an older GPT 3.5 model. So I don't believe this is in the training data of the current turbo model, although they are changing them, so it might. But in any case, you can also use the older models and it will do the same thing. All right, that's cool. I can ask more questions. Tell me about these embeddings. It will do, and it will give me a citation again. I suppose in the citation here, I would have liked to actually generate these citations. So put together the authors and whatever else in there. And yes, you could prompt it to do so. But obviously in this use case, it's a bit of a silly use case, because in reality, you would probably just pull in the source from the document that has been used. As we're only returning one document, that is it's pretty easy. But anyway, we have that. And this is kind of useful when it's, returning stuff from its own memory. You can actually see where, what it has been trained on in order to, find that information, or in order to remember that information, which is kind of cool. Then, okay, this is where it would usually break, right? If we didn't have that error, so you can see that we're handling this error. If we didn't have that, it would just try and output, a normal sentence. Here, we see that it actually forces it to use that answer source format, which is pretty cool. And then I can literally beg this agent to not use this format, and it still will, which is, that is cool. It's useful, depending on what you're building, of course, but it's a nice little thing that we have there. So yeah, that is LangGraph. I think, this is a very basic example. There is a lot more that you can do with LangGraph, just build far more complicated agents than what we've done here. But at the same time, you can also build these simple agents, and you can make them pretty custom, like we did with, the RAG emulator and the final answer, and also the final answer, error handling. Right, we built all that, and it is not that complicated. And you can add many nodes and many different edges, and build something quite sophisticated without too much difficulty. And the code, one thing that a lot of people say, and I understand to some degree with LangChain, is that the code is very convoluted. There's a million ways to do one single thing. And I'm not saying that is perfect here, but I feel with LangGraph, it is much more refined. And we were just showing you to build a graph, you need to add the edges, you add the nodes. And yes, there are many different ways of building those nodes, but the logic is pretty intuitive and easy to follow, and simply very extensible. Right? I would use basically the same functions whether I'm building this very simple agent or some super big research agent that has a million different sources of information. We would be using roughly the same functions without too much difference. We would just be putting a lot more into it, and that is something that I quite like so far with LangGraph. And I think the other thing is just the ability to really control what your agent is doing. With LangChain, everything is kind of hidden behind abstractions, and there are still abstractions here. I will not lie, but they feel far more useful and far less frustrating than LangChain abstractions, which I appreciate. And although this can be slightly complex to get started with, after a few hours I think it becomes quite intuitive, and that is something that I just like about this library. So for now I am building agents with LangGraph rather than LangChain or the core LangChain. Of course, there are still a lot of LangChain components in here, and I'm sure I will continue using them for a long time into the future. But this is the way that I'm building the logic or the paths within agents, and I think it works pretty well. So that is it for this introduction to LangGraph. As I mentioned, there will be more LangGraph videos. We'll build some more complicated stuff, but yes, that is it for this introduction. So I hope this has been a useful and interesting video. So thank you very much for watching, and I will see you again in the next one. Bye.